welcome to the Deep Dive. Today, we're plunging into, well, the very bedrock of what makes our digital world connect. We're talking about the foundational physical components of any network.
That's right.
And whether you're just trying to fix your home Wi-Fi or you're managing, a huge enterprise system, understanding these tangible parts, the actual hardware you can see and touch, it's absolutely key.
It really is. I mean, at its core, a network is basically just a group of devices sharing data, maybe resources like printers or internet access.
Right.
But the real magic, and sometimes, let's be honest, the biggest headache, it really comes down to the physical hardware that brings it all together.
Yeah.
So our mission in this deep dive is basically to give you a shortcut, a way to get genuinely well-informed about these crucial building blocks.
Okay.
We'll throw in some surprising facts, maybe a bit of humor, keep you hooked, but without getting bogged down in super technical jargon.
Excellent. Okay, let's unpack this then.
Yeah.
Start right at the beginning, like at the device level itself.
Makes sense.
For your computer or your phone or even that smart printer to get even a single byte onto the network, it needs a special bit of hardware, right? It's kind of digital voice.
Exactly. That's the network interface card, or NIC, sometimes called a network adapter.
The NIC. Okay.
And every single device that wants to talk on the network needs one. Period.
Every single one.
Yep. It's fundamentally what allows your device to communicate. It could be a wired one, with an Ethernet port, or it could be wireless for Wi-Fi. But either way, there's an NIC involved.
So it's passport to get onto the network.
That's a perfect analogy. It's the device's passport to access the network. Without it, your computer is just, an island.
Right.
And here's something people sometimes miss. Even if you only use Wi-Fi, you still have an NIC. It's just a wireless one.
Ah, okay.
It's got that unique hardware signature, the MAC address, that really identifies your specific device, whether it's plugged in or on Wi-Fi.
Got it. So devices have their passports. Now, how does the data actually, travel once it leaves the device?
Okay, yeah. That brings us to the network's roads, essentially. Cabling.
Cabling, right. The physical pathways.
Exactly. And for your typical local network, your LAN, the main workhorse is usually twisted pair.
That's like your standard Ethernet cable, Cat5e, Cat6, that sort of thing.
Precisely, Cat5e, Cat6, maybe Cat6N now. And then you've probably also seen coaxial cable, that thicker round cable.
Yeah, like for cable TV.
Exactly. Often used for cable internet connections coming into your house.
Okay.
But here's where it gets really interesting when we talk cabling. Because we have to talk about fiber optic cable.
Right. Fiber.
Yeah. This isn't just copper wires carrying electrical signals. Fiber sends data using pulses of light.
Light.
Yeah.
That sounds fast.
It is. It's a total game changer. Makes it perfect for incredibly high-speed data and over really long distances, too.
Okay.
And here's a fun fact for you. Because it uses light, fiber optics can carry signals at, nearly the speed of light, over miles.
Wow.
It's why your internet company might be digging up the street, They're often replacing older copper lines with fiber.
Yeah, that makes sense. So, okay, devices are talking, data's flying down these roads, whether copper or light.
Yep.
But what about directing all that traffic within my network?
Yeah.
Like in my office or home. How do we make sure data goes to the right computer and not just everywhere?
Good question. That is the critical job of switches.
Switches. Okay.
What's really cool, or I guess fascinating about a switch, is how it works. See, unlike some older, much less efficient tech, a switch gets data from one device, looks at the destination address, and intelligently sends it only to the correct destination port.
So it's smart about it.
Exactly. It acts just like a traffic cop, directing data precisely where it needs to go, makes the whole network way more efficient.
Right.
And, here's the kicker. That intelligent routing, that's what lets multiple people stream HD movies at the same time on the same network without everything grinding to a halt.
Yeah. That's a big deal.
Huge leap from the old days of hubs just blasting everything everywhere.
Okay, so switches handle the local traffic, keep things orderly inside our network. But what about talking to the outside world? Connecting to other networks like, the entire internet?
Right. How does our data find its way through that massive global maze?
Yeah.
Well, that's the primary job of a router.
The router. Okay, most people have one of those at home.
Exactly. A router is the device that figures out the best path for sending data between different networks. It literally routes the data packets.
So from my network out to the internet.
Precisely. And it brings the replies back, too. Without a router, your home network or your school's network, even a big business network, it just couldn't reach websites or services outside its own little boundary.
It's the gatekeeper, kind of.
Or the global navigator, maybe. It finds the way.
Okay, navigator.
Yep.
I like that. And when we talk about reaching the internet, there's usually another box involved, right?
Yeah.
The one that actually talks to my internet service provider, the ISP.
Yes, absolutely. What's that piece of hardware?
That would be your modem.
Modem.
The modem is your direct connection to the ISP's world. Its name actually tells you what it does. It's a mashup of modulator-demodulator.
Ah, okay. Modulated, demodulate. What does that mean exactly?
It means it converts signals. It takes the digital signals from your computer and network and modulates them into analog signals that can travel over the ISP's lines, like maybe a DSL phone line or a cable line.
Right.
And then, for data coming in, it demodulates those analog signals back into digital that your network understands. It's basically the translator.
The translator. Got it.
And yeah, like you hinted, for most home users nowadays, you often find the modem and the router functions built into one single box.
Right. That combo unit makes things simpler.
Definitely does. Offers both the translator and the navigator in one package.
Okay, so we've got wires, we've got traffic cops, navigators, translators. But what about all the wireless stuff? My phone, my tablet, smart speakers? How do they get onto this network without plugging anything in? Excellent point. All this wired infrastructure is great, but we live in a wireless world too.
We sure do.
That's where access points, or APs, come into the picture.
Access points, APs.
Yep. APs are devices specifically designed to let wireless devices connect to the wired network.
So they bridge the gap.
Exactly. You see them everywhere. Schools, coffee shops, big offices, usually to spread Wi-Fi coverage over a larger area than a single home router might cover.
Okay.
You can think of them as like wireless doors into the network. They pick up the radio signals from your phone or laptop and convert them into electrical signals that can then travel over the Ethernet cables, usually back to a switch.
Wireless doors. I like that. Okay, now let's picture a more professional setup, like a server room in a business.
Okay.
You could have hundreds, maybe thousands of cables running everywhere. That sounds like it could get messy fast.
Oh, it absolutely can. A total spaghetti monster if you're not careful.
So it has to be a way to keep that organized, right?
You bet. And that's precisely where you see patch panels and racks being absolutely essential.
Patch panels and racks.
Yeah. So in these bigger setups, all the Ethernet cables coming from wall jacks or individual devices, they don't just plug randomly into switches.
Okay.
They're carefully run and terminated, punched down into a patch panel first. It's basically a panel full of connection points.
Right.
And that patch panel is then mounted neatly inside a larger metal frame, which is the network rack. Switches and routers and servers often get mounted in the same rack.
So it centralizes everything.
Exactly. It makes managing, troubleshooting, tracing hundreds of connections so much easier. Keeps it clean, organized. Believe me, you do not want to walk into a server room that doesn't use them.
Sounds like a nightmare.
It really is. Finding the right cable without that organization, almost impossible.
Okay, good to know. Now, before we move on, maybe a quick history lesson.
Yeah.
Are there older devices that sort of paved the way for what we use now?
Yeah, that's actually a great point for context. Legacy device.
Legacy devices, right.
While you probably won't see them much in new installations, you had things like repeaters. Their job was just to boost a signal to help it travel further.
Okay.
But the problem was they also boosted any noise on the line, so they weren't ideal.
Right.
And then there were hubs. Hubs were like very basic early versions of switches, kind of dumb switches, really.
How so?
Well, a hub would just take incoming data and blast it out to every single port, every connected device.
Oh, wow. Not efficient.
Not at all. Imagine every conversation in an office being yelled out loud for everyone, even if it was just for one person. That's a hub.
Yeah. Okay. Switches fix that.
Exactly. Switches brought that intelligence, that targeted delivery. And you also had bridges, which were mainly used to connect two separate network segments together. Often had performance limits.
Interesting.
Yeah, these are rarely used today for, new stuff.
Yeah.
But they definitely show up on certification exams like CompTIA network plus.
Good to know.
So still worth knowing about just for that historical context and, well, exam prep.
Definitely. So, okay, we've talked about all these different pieces. NICs, cables, switches, routers, modems, APs, patch panels. What does this all mean for you, the listener? How do they actually work together in, say, a real-world scenario, like a small business network?
Okay, yeah, let's paint that picture. Let's visualize a typical small business.
Perfect.
So you've got maybe several computers, right? Desktops. Those are usually plugged into a switch using those Ethernet cables, the twisted pair ones.
Okay, computers to switch. Got it.
Then that switch usually connects to the router.
It's a Christian router.
Okay, a router in turn plugs into the modem.
Router modem.
And the modem is what actually connects out to the internet service provider, giving the whole network internet access.
The final link.
Right. And then for any wireless devices in that office laptops people carry around, maybe phones on the Wi-Fi,
Yeah.
they connect through an access point or maybe multiple APs if it's a bigger space. And those APs, they're also wired back into the network, usually plugged into that same switch.
Ah, okay. So it all connects back to that central switch infrastructure.
Pretty much. It forms a cohesive chain, you see. Data flowing from computer to switch, maybe to router, to modem, out to the internet, and back again. Each part playing its specific, crucial role.
That makes a lot of sense when you lay it out like that. This has been super insightful, really explaining how these networks get built from the ground up.
Glad it's helpful.
But let's bring it back to the listener. Why does knowing about NICs and switches and routers really matter to you beyond just, general curiosity? What's the practical takeaway here?
Oh, the practical benefits are huge, actually. First off, it really empowers you to troubleshoot problems more effectively.
How so?
Well, instead of just randomly rebooting everything when your internet goes down.
Which is what most people do, right?
Exactly. You can start thinking systematically. Okay, is the cable unplugged from my computer's NIC? Are the lights flashing on the switch like they should be? Is the router talking to the modem properly? You can actually diagnose things logically.
That makes sense. Pointed troubleshooting.
Right. Second, it's completely foundational if you're even thinking about getting into IT or networking as a career.
Yeah.
This stuff is the basics.
So like for certifications?
Absolutely. It prepares you directly for industry certifications like CompTIA Network plus Santa A plus ANILA and others. This is chapter 1, basically.
Okay.
And ultimately, I think it just builds your confidence. You move beyond just being a user of the network to someone who actually understands how it works under the hood.
Yeah, I can see that.
That lets you understand how to design networks, support them, manage them in the real world. It gives you that fundamental grasp you need to really interact with and maybe even innovate with the technology.
That's powerful. So just to quickly recap our deep dive today, we journeyed through the key physical bits. The network interface card or NIC,
The passport.
the different types of cabling like twisted pair and fiber,
Roads.
the intelligent switches directing local traffic,
Traffic cops.
the global connecting rotors, translating modems,
The lights.
the wireless enabling access points,
Wireless doors.
the organizers like patch panels and racks for bigger setups,
Keeping it sane.
and even a quick look back at legacy gear like repeaters, hubs, and bridges.
Right. The history lesson.
There's quite a lot of hardware when you list it out.
It is. And, this really raises an important question, I think, for you to consider. How does truly understanding these fundamental physical building blocks empower you, not just to fix things when they break now, but maybe to creatively adapt and really understand the next evolution of network technology? Because the specific boxes might change, the speeds will definitely increase, but the core functions, connecting devices, routing data, translating signals, those tend to persist.
It's a really interesting point. So understanding the why helps you adapt to the what's next.
Exactly. So I'd encourage you, look around, observe the networks near you, your home setup, your office, that coffee shop Wi-Fi. Now that you know what to look for, see if you can spot the pieces and how they might be connected.
That's a great thought to leave everyone with. Really makes you see the invisible infrastructure around us.
Hopefully.
Well, thank you for joining us on this deep dive into the physical heart of networking. Really appreciate the insights.
My pleasure.
We'll catch you next time on The Deep Dive.